19 kids on my team. Please buy one with their names on the back. That means I have to do this equation. I have to put in x equals 19 in this equation. That means I'm going to take 9 times 19. And if it's less than, this is where you use the 150. So some of you tried to use the 150 in that equation. The 150 didn't belong in the equation. If this amount is less than 150, when you put it in your calculator, then you can buy it. And if it's more than 150, he can't buy it. And then you're asked to explain if he could buy those or not. So that was how you were looking at that one. If you would then turn back to the front relationships. Key thing, proportional relationships will always start at 0, 0. Please write that in your notes. Proportional relationships will start at 0, 0, and then they will be a straight line. You got to be writing. It's a good thing. So start at 0, 0, and when we talk about a proportional relationship, it will always go through our graph at 0, 0, and it will have a constant rate of change. So it will always be a nice straight line when we look at proportional relationships. We're going to be talking about their slopes in this unit. We're going to talk about tables and graphs. As we read our vocabulary for this one, it says a proportional relationship is any relationship between things that change together. In other words, equal ratios. Now, equal ratios means that we are comparing, usually, we are almost always going to put our dependent variable, so please write dependent, which is which letter, X or Y?
Well, what?
Y is dependent, right? We're usually going to take our dependent and divide it by our independent. Independent is X. It is simply a ratio of two numbers. In this situation down here, it might be 3, because I'm going to write cookies, per $1. That's one way of writing that ratio. Someone else might have written it this way. They might have written it as $2 per 6 cookies. Now, these don't simplify to the same things, but this one does simplify to $1, right, per 3 cookies. So it kind of depends on how you're trying to write it. And a lot of times when we talk about our unit rates, we want the denominator to be 1. So this way might not be the rest because we want to usually find out how many cookies we could buy for $1. So using this one, right below here, how much would 12 cookies? I would like you to put the ratio, 3 cookies to $1 equals, where should I put the word cookies? The 12 cookies, numerator or denominator? On top. So 12 cookies. What do I do to 3? What do I multiply by 3 to get 12? Times 4. So I should have how many dollars down here? Should be $4, right? So I'm going to continue with that same ratio as I am looking at that. Okay? So on the top on that next page down, you are asked to graph those relationships. So if we are taking a look at graphing them, it says you go to a grocery store and you want to buy egg salad at the deli counter. The cost is $2, for 2 pounds is $6, and we want to display this. So in your homework tonight, I'm going to give you something like this. If we are displaying it, we are going to put it first in our table, 2 and 6, goes through 0, 0. You want to take your straight edge, and as you take your straight edge, you want to extend that line, and please put an arrow on the end, okay? Because even though our graph stops at this point, it would continue. So we had 2, 6, we had 4, 12. If I asked you to find the unit rate would be, when we are looking, your label down here, please make sure you put pounds. Please make sure over here we put dollars. Anytime you graph for me, you need to have labels on both sides. So some of you I've noticed have drawn your line, but you didn't put the labels. So please make sure you go back and put these 2 labels on your graph. I would also like, if I saw your graph, that I can see that you put these 2 ordered pairs by it. If you wanted to put more than that, you could, but I for sure need those two. All right. So as we are reading on this one, Amy, would you read please at the top of page 6?
Mary Ann is traveling with her distance and time shown on the graph below. Page before on the graph are described the proportions that are represented by them. When you describe a proportion, you should use the dependent variable first, then the independent variable.
So it tells us, which one do we want to go first with, James W? What did she just read? Which variable first? But what did you want to read this again? When you describe, would you read that out loud again? And then what? So please put dependent. And then a lot of times we're going to use the word per or independent. Okay? So please write that up top. And it says we're picking different points. So as we are looking at this one, Michaela, where would this point be right here? Like where would you call that? 1 what? 115. Okay. Olivia, if I'm looking at another point, you can pick any other one here. 30. Okay. It might be easier looking at yours. Okay. So when we are looking at this, so turn to right in your notes. They are asking us to write it in words. So the first way I might write this is I might say that I'm going 15 miles in 1 hour. Someone said, what if I don't like using the word in? Could I put 15 miles per 1 hour? Yes. I want you to write for these other points. Please do that right now. When you are writing, describing a proportion, if they don't ask for your unit rate, you can have it described many ways. So you could have had 60 miles in 4 hours. You could have had any of these, or notice that you could have this one. So I just want you to be aware of that. $6 for 2 pounds. Can you find out how much 1 pound costs?
Yes.
Okay, so I want you to write that down. Make sure you use labels with it. We're going to talk about the definition in the video of the unit rate, and then I want you to think about this question and circle on yours. As you take a look at this graph right up here, I want you to think, is this a graph of dollars per pound or pounds per dollar? Thinking about, we are always looking at our dependent variable per our independent variable, okay? So we're going to watch this video where I'm going to get that definition of a unit rate for you.
How do you find how fast something is going from a graph showing the time that has passed and how far it has gone? In this lesson, you will learn to find a unit rate by using a graph. You've already learned that if you have a proportional relationship like $6 for 2 pounds, you can make a table of values and graph the relationship. You've also already learned what a unit rate is. A unit rate answers how many dollars for 1 pound in this case, or in general, how many of the dependent variable for 1 of the independent variable. In this example, we would find the unit rate by dividing 6 and 2 by 2 to get $3 for 1 pound, or $3 per pound.
Right on the middle of page 6.
A common mistake is to reverse the variables when giving the unit rate. The number of dollars for 1 pound, not the number of pounds.
So, when you are looking at that, I would like you to take a look at what they have for this definition right here.
So for example, if you're looking at this graph,
so, unit rate, please write this down. The number of the dependent variable per 1 of the independent. So this is right on the bottom of page 6. Please write that right now where it says unit rate. I will put it up again for you in a few minutes. Okay?
Is going to be the number of dollars for 1 pound, not the number of pounds for $1. Suppose you have a table and a graph of a proportional relationship. Let me show you 3 very important ways to find the unit rate, all 3 of which are important. Since a unit rate means the number of dollars for 1 pound or the number of y's for 1x, you can just find 1 in the independent variable column or on the graph and then see what corresponds to it. From either the table or the graph, you can see that the corresponding number is 3, so the unit rate is $3 per pound. Another possibility is to pick any ordered pair, such as 4 pounds cost $12, and divide. 12 divided by 4, again, gives you $3 per pound. Again, from the graph, you could pick the ordered pair, find the 2 numbers that the ordered pair represents, 12 and 4 in this case, and divide, and you get $3 per pound. A third way to find the unit rate is to look at any ordered pair, such as 4, 12, and then say, okay, suppose at the last minute I decided I wanted to buy 1 additional pound. How many additional dollars would that 1 pound cost? From 12 to 15 is 3 additional dollars, so it's $3 for that 1 pound. Or on the graph, suppose you were planning to buy 4 pounds, that would cost $12. If you decide to go with 1 additional pound,
so these 3 ways, we're going to write these down.
That would take you up from $12 to $15. That difference of $3 for that 1 pound is the unit rate.
Bottom of page 7 is what you're doing.
What's the unit rate for this proportional relationship? Well, in this case, the fastest way is just to find 1 on the x-axis and see that 1 hour corresponds to 2 kilometers. So the answer would be 2 kilometers per hour. What's the unit rate for this proportional relationship? Notice that this time there are breaks in the scales, which means we can't just look up 1 on the x-axis because it's not visible. Well, we can use one of the other methods. Pick any ordered pair on the graph, find its coordinates, and divide. 30 miles in 10 hours. 30 divided by 10 is 3 miles per hour. One more example. What's the unit rate here? This time, not only do we have breaks in the graph, so we can't look up 1 on the x-axis, we also don't have labels for the scales at all, although I will tell you that 1 tick mark equals 1 unit. Here we need to use the third method I showed.
Put a point here.
Pick any ordered pair on the graph.
Make that a point on your graph.
And imagine that you knew its x and y coordinates. To find the unit rate, imagine that you decided that you wanted 1 more pound than you had planned.
Put an order.
Find the corresponding tick mark on the y-axis. And you can see that that 1 additional pound resulted in a cost of 4 additional dollars. So even without seeing any specific numbers on the axes, we know that the unit rate is $4 per pound.
So when I'm looking at yours, your notes should be totally filled in at this point. So we've gone through all of those notes, right? We filled in this answer here when we were taking a look. You should have had back, so we are back now. If you want to turn back to page 5 or 6 at the bottom of page 6. $3 per pound. Which one should I have circled on my graph? Dollars per pound or pounds per dollar?
Pounds per dollar.
What is my,
Dollars per pound.
I have to go with my cost first. It's always y per x. So you should have circled this one. This is what I had for unit rate. It's the number of the dependent variable per 1. So it is always whatever number is your dependent variable per 1 of your independent. So it's 1 on the independent and whatever number it happens to be on that dependent variable, okay? Whatever number that happens to be. So, on the top of the next page, these are the 3 ways that I want you to write down, okay? So I'm going to give you these 3 ways. They said them. I need you to write them as I'm writing them. There's going to be 3 of them, okay? So as you are looking at what are the 3 different ways that we can find the unit rate. The first way, find 1 on your independent variable. Which one is independent? The x. So find 1 on the independent. That's x. I don't care if you find it in a table or a graph. So please write this out, Gavin, you're writing. Okay. So if I look here, or if I look here, right? Find 1, the independent on the table or the graph, and I notice the number that corresponds to it. And then I look for the y value, or your dependent value. And in this case, we would say that our unit rate is $3 per pound. Second way that we are going to be looking at. The second thing, so I'm going to talk about when we do our homework today, the 3 methods. So please write, pick an ordered pair. What do I mean by an ordered pair? I mean an x, y value. So pick an ordered pair, x, y. And then you are going to divide. What did we keep saying? We're dividing the dependent, y, divided by x. Y divided by x. And you're going to make sure that when you write it per 1. So if it's 6 divided by 2, you're going to change it to 3 over 1. If it's 6 divided by 5, that comes out to be 1.2 per 1, right? So when we look at that, that's how we're going to solve that. The last one is you are going to look at an ordered pair. X, y. And this time we're going to determine 1 more on the x. So wherever this point is, we're going to move over 1 unit, okay? And we're going to look at how does the y change. So when I am looking at your last 3 examples on the bottom of page 7 and page 8, these are the 3 methods. Problem 5, we use method 1. I'm going to give you a minute if you need to write this down so that you can take a look at that. On this next example, this is method 1 because they gave you a 1 and you went here and you found, and this is the one you just filled in from the video, and you said, oh, that if I am looking at this one, it should be 2 kilometers per hour. This was method 1. So if I was looking at this, I would put down, this was when I solved this was using method number 1 from those 3 that we just wrote down. On the top of page 8, we have a broken graph. And they said, you know, when you have this broken graph, you cannot tell exactly where 1 is. So what you have to do is pick a point. And they picked this point right here as we were looking at this one. So if we are looking at this point, what I asked you to write down is the ordered pair, 10, 30. And then what we were looking at was taking 30 miles per 10 hours. And you should have wrote down, this was method 2 that we just solved. Method 2 is to always take your y coordinate, which is 30, and divide it by our x coordinate, which was 10. The last method, this is method 3. So in method 3, on your graphs today, you have no numbers. But what you notice is that you are moving 1 unit over, so per 1 pound, okay? So this is 1 pound. How far did we go up? We went up 1, 2, 3, 4. So because we went up 4 as I am looking at this, my answer was $4 per pound. And that was simply by using those 3 methods. So when you do your homework tonight, it's going to be very similar. You're going to keep referring back to those 3 methods as you look at your work. Okay? So, page 46, and it is actually not through 49, it's through 48, but there are 3 pages. It gets a little longer when you have all these graphs to get everything filled in and written in. I'd like you to go right now to question number 1, and we need to decide what are our axes on our graph. So as you look at the problem, okay, it says egg salad is purchased at the deli counter, 3 pounds for $2. What label should I have over here on my dependent? What do you think, man? Dollars. Which means I have to have pounds down here. Please put the numbers, right? Probably going by 1 pound, 2 pounds, 3 pounds. Someone said, could I go by a half a pound and have 0 and then have a tick mark and then have this be 1 pound and this? You can do that, right? Or if you want to go every single one. So please fill yours in. And then your dollars, I would say you're probably going up by 1. Fill yours in. Do this now. Next thing is we look at the problem. I need to plot the point. 3 pounds for $2. So if this is my $2 and I'm going by ones here, $2, I'm going to go to this point. Does it tell us it is proportional? And in this case, time should be in years, which means this is going to be the height. So all of your graphs need to have labels, okay, when you're doing these. Do you have to always go by ones? I would for my years. I would probably go with 1 year, 2 year, 3 year, 4. But for my height, I might go by 2, right? Because I have to go up to 8. And if I just go by ones, I'm only going to get a couple dots on my graph. Someone said, instead of using 2, could I use 4, or could I use a different number, 4 or 8? Sure. Just make sure you tell me what your labels are. Label, put your numbers. So all of these should be nice, straight, raised, all starting through that point 0, 0. As you do your homework, check. Make sure that you're doing them right. These are kind of my hints as you looked at that first page. Please get started now.